students, we are taking the effect of dielectrics on the capacitance of a parallel plate capacitor. Now it is applicable for all types of capacitors. Now dielectrics are basically the insulating materials. Now insulating materials can be of two types, polar and non-polar. So when we say non-polar, then in that case the centers of positive and the negative charges, they coincide each other. So in that case there is no permanent dipole moment. And in non-polar, the centers do not coincide, so they have a slightly permanent dipole moment. Now when we place it between the plates of a capacitor, say this is positively charged and this is negatively charged, so whenever we place the dielectric in an external electric field, because now the electric field is there whose value is Q upon epsilon naught A, means the sigma upon epsilon naught between the two plates. So whenever we place the dielectric in the electric field or external electric field, then there are two options are there. In case of polar molecules and non-polar both, they develop a slight dipole moment because of the induction of charges or the movement of the dipoles. Now if you see here, so we can say if this dielectric we have filled in between the space of the plates, then this charge is positive, this one is negative. The negative charge will be induced on this surface and positive charge will be induced in this surface. So we can say for external field, direction is always positive to negative. The electric field is from first plate to second place. But inside the dielectric, the induced field is in the opposite direction. Means from negative to the positive plate in external circuit. So because of that, we can say between the plates, the electric field decreases. Since the electric field decreases, so it means the electric potential also decreases, your potential difference also decreases. So that way we can say when the potential difference decreases, then the capacitance increases. Means now to raise to the same potential, now we can give it more charge. So that way we say if the whole space is completely filled with the dielectric, then the net electric field, means the new electric field between the plate is given by E naught upon K. And final potential difference is also given by V naught upon K, where K is dielectric constant of the medium. This derivation we have done for the parallel plate capacitor, but this definition of dielectric constant is applicable for all capacitors, whatever be the shape. So that way in general this reasoning, means this electric polarization of dielectric can come in 2 marks. They have asked it twice or thrice in the board exam. So this formula means net capacitance is K times of original, net electric field is 1 upon K times of original, net potential difference is 1 upon K times of original. That way this is applicable when the whole space is filled with the dielectric. Now say for example we are having another situation where the space between the plate is not completely filled with the dielectric, but a part of that is filled with dielectric. Say spacing between the positive and the negative plates are d and thickness of dielectric is small t, and the area of plate and the area of dielectric slab is equal. So you know in one thing, net potential will be V1 plus V2. V1 we are taking the space where the air is there, and V2 we are taking inside the dielectric. So we have the value by V is E into D, E naught into D minus T plus E into T, where E is modified electric field. So we get the value, that is sigma upon epsilon naught, which is the original electric field between the two plates, into D minus T, upon it will be 1 upon K times of original into T. So on solving and taking the terms common, we get the value of net capacitance as epsilon naught A upon D minus T plus T upon K. So if we completely fill the space, then we can say D and T will be equal. In that case again the same formula will be there. K epsilon naught A upon D means capacitance will increase by a factor K. If we fill the conducting slab between the two, so you know inside the conducting slab value of electric field is 0 because the charge will flow from one point to another. So we can say for conductors K is infinite. If we put it in that, we get the value epsilon naught A upon D minus T. So in the exam when they are giving the derivation, so normally this derivation comes for 2 marks. So read carefully whether they are saying dielectric slab is placed between the plates or the conducting slab is placed between the plates, because accordingly the answer will change. And if to a more dielectrics are filled, means of different materials you can say, the net capacitance will be epsilon naught A upon D minus T1 plus T2 plus T3 for different dielectrics, plus we can say T1 upon K1 plus T2 upon K2 and so on, means the general formula. Now in next video we will cover the topic series and parallel combination of capacitors.